Good afternoon. We're going to take a little bit of a different course at this point. Well, many of our speakers will be presenting the results of their pilot projects. We want to pause for a moment to actually remember a couple of our colleagues who in the Dillon-Carnahan keynote speaker. And so just a brief bit of history, but you know, one of the joys of being a faculty member is seeing, you know, almost literally generations of students transitioning to practitioners, becoming senior people, and really influencing and having an impact on the health and well-being of workers. The other side of that is that there are just some faculty that are particularly good at engaging with students, and they become really good role models. And Ken Dillon and Brian Carnahan were really two of those kind of faculty. I knew Ken Dillon from the University of Alabama, Birmingham, and it was that he was really the kind of leader faculty that we appreciate. Brian Carnahan, I regret to say that I didn't meet him. He was at Auburn and also passed away about the same time. I think it was, you know, a good decision on the part of the ERC at UAB and Auburn to develop this program centering around the Dillon-Carnahan. And years ago, I was actually invited to be the speaker at their meeting, and I was so I have that little bit of a historical link. But they brought that to this gathering of now SERRS, and I think it's one of these things that's a valuable contribution. So today's speaker is David Zierden. David is a graduate of Florida State, and I personally don't hold that against him. They have a good meteorology program, and he got both his bachelor's and master's degrees from there. He then went immediately to work for the under the mentorship of the state climatologist at the time, Dr. James O'Brien, a recognized expert in oceans and climate, and he went there as the assistant state climatologist, and now has been appointed the state climatologist since 2006. So that's 16 years or thereabouts of watching the challenging climate of the state of Florida. I think somebody once described it as really three climates as you move north to south. Okay, but anyways, David, please come up. His topic is going to be on the climate change, variability, and some implications for occupational safety and health. Thank you very much. This will advance the slides.
All right, thank you very much for the kind introduction. I can hardly measure up to Mr. Dillon or Mr. Carnahan, but it's an honor to be here. And speaking of the University of South Florida, my youngest son was this close to enrolling last fall, but unfortunately the hometown university, FSU, won out, and he's now a Florida State Seminole. So again, it's a pleasure to be here. I'm hardly an expert at occupational health and safety, so I'll try to make some connections where I can, but I do know weather and climate pretty well, so that is what we're going to focus on today, and hopefully there will be a lot of crossover and a lot of good discussion. So with that, we'll go ahead and get started. A little bit more about myself. Speaking of this picture I have on my cover slide, you may recognize this. This is a photo from the inside the eye of Hurricane Michael as it made landfall at Mexico Beach. I grew up in Panama City, Florida, and it's changed so much since I was a young child, but that's beside the point. We always knew that the big one was a possibility. Well, Michael truly was the big one, and this is a spectacular photo. You see nearly every tree in this pine stand in Tyndall Air Force Base is downed. We're inside the eye. You see the sun shining, and if you look closely, you can see the eye wall with that stadium-type structure that's really indicative of a very strong and mature hurricane. So really is a spectacular image. There's actually a 5-minute video of this on YouTube done by some storm chasers. But so that one hit close to home, but with that, we'll go ahead and delve further into climate and weather. And before we do that, let's talk about some of the climate and weather threats. And the main ones that we experience here in Florida, I've got listed. Changes in temperature and extreme temperature, extreme rainfall and flooding. On the other side of the table, we have drought and the lack of rainfall. Sea level rise, we know that well living here in the state of Florida and the threats that it brings. Hurricanes and tropical storms and severe weather. So these are our main weather and climate threats. Now here's something that may be shocking. Climate change is not bringing any new climate and weather threats. These are the same ones that have existed throughout human history. But that doesn't mean that climate change is not changing their nature, their frequency, their severity. And we'll go into that as I go through this talk. And one other little bit of background, risk modelers will cringe at the oversimplicity of this model, but a very simple model is that risk can be thought of as the threat or the probability of an extreme event times the exposure. How vulnerable are you to these extreme events? And it can be represented like this graph on the lower right there. Where you want to be is you want to be in that bottom left-hand corner where it's a low risk or low threat and low exposure. Well, the only way to move towards that favorable portion of this graph, as I'll show you throughout the talk, the probability or the threat of these extreme events is not going down. So the only way to get to the more favorable portion is by reducing your vulnerability or your exposure. And over on the right, here's a good example of that. This is again from Hurricane Michael at Mexico Beach, Florida. You see, city blocks have just been wiped away by the storm surge that occurred there of 15 to 20 feet, except for this one building that remained relatively unscathed. Well, that was built by a private citizen, a retired engineer who designed it to nearly twice the building standards and really fortified it against hurricanes. And it came through well. It's reduced its exposure. However, it cost several $1 million to build, so I'm not sure that's a good model for longtime citizens, lower to middle income families that have lived along the coast all their life. So now we'll delve into the climate and what's going on here. And I think everyone's familiar with this graph. We've seen it thousands of times. It's called the Keeling curve. It's a very accurate measurement of carbon dioxide concentration in the atmosphere taken at the top of Mauna Loa in the Hawaiian Islands. Being a very pristine location away from continents and development, it's a very good representation of the global average carbon dioxide concentration. Well, the beginning of this record, starting back in the mid-1950s, we were at about 315 parts per million of carbon dioxide. As you see, there's been a steady or even exponential increase in carbon dioxide concentrations to now we're up over 420 parts per million. And this is the direct result of the burning of fossil fuels and human activity industrializations. This is not debatable. This is what we're doing to our atmosphere. Even more alarming is scientists for decades have been researching in Antarctica and taking ice cores samples down several thousands of feet, and the ice is deposited in layers almost yearly, and by looking at the air bubbles trapped in these ice cores, they can determine the carbon dioxide concentrations back. This graph goes back 800,000 years over several different ice ages and warm interglacial periods. And what's alarming on this graph, if you look at the far right-hand side, that's the last century and what humans have done to the atmosphere. No time in the last million years or more have greenhouse gas concentrations been as high as they are today. Again, this is the grand experiment that we are doing to our atmosphere and doing to our planet without really knowing the end result. So, at the same time with these increasing greenhouse gas concentrations, there's also been an increase in global average temperature. And this is another very familiar graph. I think we've all seen a version of it. Going back to about 1900, or really the start of industrialization, there's been a steady rise in the global average temperature where we're now at over 1 degree Celsius of warming since pre-industrial times, and we're rapidly approaching that 1.5 degree threshold. So again, temperatures are rising just as the theory says they should. Also, if you notice on this graph, the last 8 years have all been the 8 warmest on record in this global average temperature record. 2022, thankfully, we got a little bit of a reprise. It only ranked 5th warmest. 2016 is still the warmest on record. But there is this variability, these kind of stair-step rise, but the increase in temperature is undeniable. But this doesn't tell the whole story. If you look at this map on the bottom right, it shows the temperature change over the United States in the 20th century. And you see the West is warming pretty dramatically, but the Southeast United States, Mississippi, Alabama, Central Georgia, it actually showed a little bit of a cooling trend in the latter half of the 20th century. And this was known as the global warming hole, if you will, because it was the one place on the global map where there really wasn't any warming in the 20th century. As I'll show later, since we've gone into the new century, since 2000, this global warming hole has slammed shut, and we are quickly catching up with the rest of the country. So let's take a look at that. Here's a map of a 5-year average of temperatures over the United States. And the data goes back to 1895, and everywhere you see the dark red, the last 5 years have ranked in the top 10 warmest. Where you see the really deep dark red, Central Florida, parts of the Northeast, the last 5 years have been the warmest on record. So some astounding statistics for the state of Florida. Looking at statewide average temperature for Florida, only 7 individual months in the last 8 years have been cooler than normal. All the rest of those have been warmer than normal. And that included a streak of 31 months in a row of nothing but warmer than average temperatures. 9 months of record warm. And interestingly, overnight temperatures are affected more than the daytime highs, which has a lot of implications for occupational health and safety. And if you look at this graph on the bottom, this illustrates the trend over Florida very well. Again, this is the 5-year running average of temperatures across the state since 1895. And we see since in the last 6 to 8 years or so, we're now running nearly 2 degrees Fahrenheit warmer than any other period on record. So we've seen a fairly abrupt shift in warmer temperatures here in the state of Florida just in the last 5 to 10 years. A review of 2022, the calendar year of 2022. Again, the dark orange shading is top 10 warmest. The deep red shading is the warmest on record, which includes Central Florida, especially the Tampa area, and also southern Texas. So again, this trend of nothing but warmer temperatures continues as of today. So I've talked a lot about average temperatures. So why does that matter? What's the difference if we're 1 or 2 degrees on average warmer than we used to be? Well, it's not just the average that's changing, it's the whole distribution, the whole bell-shaped curve, if you will. And this is a good illustration from Climate Central. It shows as the average changes and shifts to the right towards warmer, it really amplifies the changes at the extreme or the tails of the distribution. The extreme heat days, many more of those, less of the extreme cold days. So we're not just looking at changes in average, we're looking at changes in the whole temperature distribution. So let's take a closer look at some extreme heat measures. And one, greenhouse gases and climate change is not the only thing affecting temperatures. There's also land use and land cover changes, especially urbanization. The vast increase in concrete and asphalt in developed areas. And this is a study from Marshall Shepard at University of Georgia, where he looked not only at the urban centers, but also the impacts of urban sprawl. And curiously, that Southeast Florida, Miami, West Palm Beach area was the #1 area in the country affected most by this urban heat island effect. So not only do we have the whole background climate changing, we got local climate impacts also that increases heat and heat exposure. So let's start talking about some measures of heat and how it affects human physiology. And we're all familiar with heat index. It's a way of combining the compounding effects of heat and humidity, temperature and humidity. And pet peeve of mine is when somebody comes up to me and says, oh, it's like 95 degrees today and 95% humidity. No, the atmosphere doesn't work that way. The warmer the air temperature, especially in the afternoon, the more water vapor it can hold, so relative humidity actually goes down in the afternoon. So 60% relative humidity and 95-degree temperatures are still quite a threat. So heat index tends to combine those, and the top graph just shows the different values of heat index depending on heat and humidity. But also, I'm going to pick on Miami a lot during this talk because I got a lot of material prepared for it. But this shows various levels of heat index over the last 50 plus years for the Miami International Airport. And we see at the heat index of 90, 95, and even 100, we see an increasing trend, especially over the last 10 to 20 years. So it's not only the temperature that's increasing, it's also the heat index. And then there's one more slide. This is just a climatology of heat index at Miami at the different levels. You see the greater levels up over 100. There's a lot of year-to-year changes in the red and the orange on how many of these days or hours at this kind of dangerous heat index level occur. But generally there is an increasing trend. Now there's another measure of how heat and humidity and other atmospheric variables influence our physiology, and that's, how many have heard of wet bulb globe temperature? Probably everyone in this room, because this is what you guys do. Wet bulb globe temperature not only factors in the air temperature and humidity, but also wind speed and the amount of sunlight or solar radiation. And it's much more closely tied to human physiology than just heat index. This is a taken from a colleague, Chip Conrad, at the Southeast Regional Climate Center, so I'll give him credit for all of this. But he's worked up a tool to help predict wet bulb glow temperature. And a little background, he got this from, what is it, the OCEA. It's a health and safety group that advises the military, and they have very strict standards on the amount of work and exposure someone should be exposed to at different levels of this wet bulb globe temperature. So I don't know if OSHA has something similar, but it's very appropriate. And they also did a climatology of this wet bulb globe temperature. This is the number of days at that yellow or higher level from that previous chart. And we see the Mississippi Valley is kind of the epicenter for where they have the most days at these dangerous levels. North Florida also, not as much for South Florida, if you can tell the difference in the shading. And I'll go into that in a little bit. But one last word on wet bulb globe temperature. It can be forecast using the National Weather Service forecast grids and such, but it's very highly dependent on your particular location, your exposure, you know, the amount of shade, the amount of protection from the wind, elevation. So in my mind, the best way to use wet bulb globe temperature is to have on-site monitoring, have a weather station, monitor all these variables, and monitor it hour by hour is the very best way, both for occupational health and safety and for outdoor recreation, sports, etc. But speaking of that, South Florida, kind of different from North Florida, this is an interesting fact that some may know, some may not know, is that it's actually North Florida is more vulnerable to extreme heat than South Florida. South Florida, we're surrounded by water. Once the summer kicks in, we get these persistent easterly trade winds off the Atlantic Ocean that really helps moderate temperatures. Where up in North Florida, in that pink shading, they can expect to see 100-degree days almost every summer, where it's a rarity for South Florida. And a couple graphs to help illustrate this. Again, picking on Miami. The top graph shows the number of days each year since, 1940 or so. The number of days each year where the temperature reached 95 or above. And we do see an increasing trend, especially in recent decades, for these 95-degree plus days. The bottom graph shows the number of days that reached 100 degrees. And there was only one at Miami, and that was back in 1942. None since. So that kind of illustrates how South Florida doesn't see the extreme temperatures that inland Florida, South Georgia, South Alabama can see. But also I mentioned how this trend of increasing temperature across the state of Florida, we're seeing it more in the overnight low temperatures than in the daytime high temperatures. And this is a great illustration of that. This wavy graph I have on the top right shows the average overnight temperature for the North Florida region back to 1895, and this is just for the summer months. And we see, starting about 1990 or so, a dramatic rise in these overnight temperatures of 2 to 3 degrees Fahrenheit. So this just illustrates how we're seeing the increase in temperature more during the nighttime temperatures and also during the warm season. But this has big implications too. I talk a lot with agriculture and work a lot with extension, and leads to elevated soil temperatures and loss of productivity in their row crops. Cumulative stress on livestock, chicken, beef, poultry, etc. Heat-related illness and stroke, especially for low-income workers who are doing agricultural work, and they might not have air conditioning. They don't get the amount of recovery they need at nighttime, and so that can lead to problems with heat-related illness and heat stroke. Another vulnerable population, I just learned this last year, You know, 70% of Florida's prison population is un-air conditioned. That blew me away. So there's a large prison population out there that is vulnerable to this increasing heat, and especially the overnight heat. And one more talk on warming temperatures. Again, this further illustrates these warming nights we're seeing. According to the U.S. National Climate Assessment, they term a warm night as a night that the temperature never falls below 75 degrees Fahrenheit. And here's, again, picking on Miami, the number of warm nights each year since 1940. And we used to average 40 to 50 of these warm nights a year in Miami. Now we're up to over 150, or nearly half the year, with these warm nights that never fall below 75 degrees Fahrenheit. And 2022 was no exception. Here's historical rankings by weather station across the state for the calendar year 2022. The dark red boxes are where they're in the top 5 warmest. The really dark red ones are where they are the warmest, set the record for the warmest year on record, and that includes Fort Myers and Tampa. But let's switch gears now and talk about extreme cold. This is kind of an interesting sidetrack. Dr. John Attaway, who was at the University of Florida, a recognized citrus expert, wrote a book about the history of Florida citrus and these severe freezes. And he identified a dozen or so of these, what he called impact freezes, that had a catastrophic effect on the Florida citrus industry. And if you look at this list of impact freezes, a couple things stick out. One, they tend to come in clusters. 1894 through 1899, several of these really catastrophic freezes that actually pushed the citrus industry out of northeast Florida, the St. Johns River and such, pushed it further south towards Orlando. Then we see 1977 through 1989, another series of devastating freezes. That and Disney World kind of killed the citrus industry around Orlando. Now it's moved further south down towards Immokalee and west central Florida, southwest Florida. But also, you notice we really haven't had one of these since 1997. And just as an aside, I'd love to talk about this. Kind of the granddaddy of them all was in February of 1989. It was called the Great Blizzard. We set the state record for lowest temperature that day, -2 degrees in Tallahassee, Florida, the only sub-zero temperature ever recorded in the state. We had measurable snow from the panhandle of Florida all the way to Tampa and Jacksonville. And here's an iconic photo that's still in the old Capitol at Tallahassee of legislators having a snowball fight on the steps of the Capitol. Key West and Jupiter, Florida were the only weather stations east of the Mississippi that did not record freezing temperatures. My question is this kind of cold event still possible with the background climate changing the way it is? I'll leave that as an open question. And trends in extreme cold temperature, again, picking on Miami. This plot shows the number of nights where the temperature got 40 degrees or colder at Miami International Airport. And you see, for decades, it was fairly common occurrence, some years more than not, but at least every other year they'd experience sub 40 degree temperatures. Well, that's until about 2000. Then they kind of abruptly stopped. 2010 was an anomaly. We had a very cold winter that year, and what would they record? How many? Six or seven nights with sub 40 temperatures in 2010. But since 2010, only one night of sub 40 temperatures. And that even includes this year, where we actually had a pretty significant cold outbreak right before Christmas. This map on the left shows what the minimum temperatures were across the region. Everywhere in that light blue, we had temperatures of 20 degrees or less all across the Panhandle and North Florida, extending into north central Florida. Sub-freezing temperatures all the way down to Lake Okeechobee. However, even with this, Miami still didn't reach that 40-degree threshold. And over on the right, you probably can't see it, but it just shows ranking the winter as a whole, December through February. Even with this cold spell, the whole region is seeing temperatures of 3 to 5 degrees above normal, even with this cold spell. All right, so harped enough on temperatures. Now let's go to another threat, and we're not going to go into these other threats in as much detail because I think the temperature story is really applicable to this group and what you guys do. But rainfall trends. Over the last 30 years, if we compare the recent 30-year period to the previous 30-year period 10 or more years ago, we see that rainfall is actually increasing across much of the country, east of the Mississippi, the northern tier of the United States, rainfall decreasing in the western United States and the desert Southwest. And we know that well. They had some relief this winter, California did, but prior to that they had been in a 4 or 5 year drought. The Lake Mead, Lake Powell levels are still very low, so they haven't caught up yet, but they did get a reprieve this year. But this is the overall trend for less rainfall across the western United States. But whether we can attribute this to climate change or not, that's still an open question. But one thing we can attribute to climate change is changes in extreme rainfall. It's very consistent with the theory. A warmer atmosphere can hold more moisture, more water vapor that's available for these heavy precipitation events. We see it in the historical record. This is from the U.S. National Climate Assessment. It shows the number of days with 3 inches of rainfall or more, which is by anyone's measures a heavy event, has pretty much increased decade by decade across the southeast region. So modeling studies back this up. All the evidence point to a greater frequency or greater severity of these heavy rainfall events. And here's a side anecdote that farmers in North Florida shared with me years ago, but they noticed this trend of more rainfall coming in heavy events and not distributed as evenly. And they didn't know what to do about it. When these events come, they cause erosion in their fields, crop damage, but also if they get more than 2 inches of rain, it all runs off. It doesn't infiltrate into the soil. So it's not there for the crops to use later. So this is their solution. During the winter, they plant very heavy cover crops. This is ryegrass that grows to overhead high. They actively grow this during the winter time, and then when it comes planting season, they terminate it, roll it down into a thick mat of mulch, and do conservation tilling right into this thick mat of mulch. And the benefits are across the board. Lower soil temperatures, less runoff, more infiltration of the rainfall into the soil, more organic matter and better nutrition in the soils. They don't have to fertilize as much. Just benefits all across the board, including making their production more climate efficient. So now let's look at the other side of the story. And this, we're going to talk about drought now. And to talk about drought, I really need to go into another aspect of climate, aside from climate change, and that's climate variability. The year-to-year or decade-to-decade changes that occur naturally. And here in Florida, kind of the mechanism that most greatly controls our year-to-year variability is the El Nino-La Nina cycle. And without going into a lot of detail, El Nino, like I have pictured here, is where along the equator in the Pacific Ocean, every 2 to 7 years, it warms up several degrees Celsius warmer than it normally is, just due to wind patterns and ocean dynamics. And this cycle has been going on for centuries. It's well known, still going on today. This shows the last two major El Nino events in 1997 and 2015, where the red shading illustrates this unusually warm water. Well, there's another side to this cycle where that same area can cool down several degrees colder than normal, and that's called La Nina. And we have been in the La Nina phase for the past 3 years. And again, that also has great implications for the state of Florida. And here's the current sea surface temperatures as of just a few weeks ago. You see the broad area of the Pacific Ocean shaded blue, where it's much colder than normal. And like I say, this is our 3rd consecutive year of La Nina conditions. And how does this work? Well, the El Nino La Nina cycle really impacts our cold weather months, November through March. And it does so by kind of modulating the jet stream patterns we normally see across North America. And here's a schematic of the typical jet stream pattern when we're in that La Nina phase or cold water in the Pacific Ocean, where the polar jet stream is the main player. We see a storm track up the Mississippi Valley, which we've been in the last couple of weeks for sure. But we also see the southern tier of the United States, the northern Gulf Coast, the state of Florida, tend to be left warmer and drier than normal when we have these La Nina conditions in the Pacific Ocean. And just on the bottom, I showed typical rainfall departures from normal when we do have the La Nina in place in the Pacific. So why is this a big deal? Well, here's a graph of the ocean temperatures in that region, where the red spikes are the El Nino episodes, or where it's warmer than normal. The blue valleys are when we're in La Nina conditions, colder than normal ocean temperatures. And what you see is that El Ninos tend to be a 1-year event, where the La Nina phase can last 2 to 3 years commonly. And I have those highlighted in the circles there, including the last 3 years over on the far right. Because it brings warmer and drier winters, which is typically Florida's dry season anyway, these multi-year La Nina events can usually bring about the onset of a long-term or widespread drought. And here, this graph shows the percentage of the state in different categories of drought since year 2000. And again, I have it highlighted when we were in this La Nina conditions in the Pacific Ocean, and it lines up very well with this widespread drought in 1999 through 2001, 2010 through 2012. But over on the far right, the last 3 years, we've luckily avoided these worst impacts of drought from the La Nina phase. So this past episode has been an outlier, and we've gotten lucky that we have not seen widespread drought. Well, we've been mostly lucky. This is the latest U.S. drought monitor as of last week, and we do see that they have most of the state designated as abnormally dry. Sneak preview, I work with these guys. When the new map comes out on Thursday, a lot of the state will now be upgraded to moderate drought, or D1. So we are starting to see the warmer and drier conditions. Certainly it's been warmer. I know that walking across campus today. But yeah, it's starting to exert itself now in this final year of La Nina. Now, I'm not going to go into a lot of detail about sea level rise. Just a couple things I would like to point out. One, changing sea levels is nothing new. This is a record of geologic indicators showing sea levels back 24,000 years ago as we came out of the last ice age. As these great continental ice sheets melted, sea level rose 150 meters or more till about 8,000 years ago. Then it kind of leveled off close to its current state. Uh, but humans have dealt with sea level rise before. If you look at that 10,000 year mark when it was rising abruptly, this was some work done by archaeologists at Florida State University, where they found artifacts and what remnants of human settlements out on the coastal shelf in 60 or 70 feet of water. So these Native Americans, that's where the ancient shoreline was. They kind of followed the shoreline and migrated inland as the sea level rose. So that's kind of an interesting story. But going back to modern times, you might say we've only seen about a foot of sea level rise in the last century. There are indications that this rate is accelerating, so that has big implications as we go out to 2100 or so. But again, you might say, well, what's the big deal about a foot or two of sea level rise? Well, this graph is from Brian McNulty at University of Miami, and it's from the tide gauge there at Virginia Key. And what I want to point out is there's this 4 foot level. And prior to 2016, that 4 foot level was only exceeded when there was a nearby hurricane and the impacts of storm surge. Since 2016, they hit that 4 foot level every year due to the astronomical, or what they call king tides, or sunny day flooding events. So this, they call it nuisance flooding, but it's actually more costly than a one-time event. And we're going to see a drastic increase in nuisance flooding all along the east coast of the United States, places like Charleston, Norfolk, Virginia, New Jersey, etc. All right, now we'll go to our last topic, our last climate and weather threat, and that's hurricanes and tropical storms. And to tell this story, I want to go back to 2016. And back in 2016, we were in the midst of an unprecedented hurricane drought, if you will. A major hurricane, category 3, 4, 5, had not hit the United States for over 10 years. At the same time, a hurricane of any strength, category 1 on up, had not hit the state of Florida in 10 years. So it was really an unprecedented drought of hurricanes. Well, there's an old saying in baseball that a player will play to the back of his card. I don't know if baseball cards are even a thing anymore, but yeah, the baseball cards, they'd had a picture of the player on the front and then the career statistics on the back. And what the saying meant is a player will go through hot spells and slumps, but in the end, he's going to play close to what his career statistics say. And this is very true with the occurrence of hurricanes. Florida broke the streak in 2016 with Hurricane Hermine that hit the Tallahassee area. And then the major hurricane streak was broken the next year with Hurricanes Harvey, Irma, Maria, Michael, and the list goes on and on. So what can we say about climate change and hurricanes? Well, first, actually the 2022 season, I don't have it listed here, was actually a little bit below normal as far as Atlantic hurricane activity. We were off the hook. We didn't see as many storms. Those in Central Florida impacted by Hurricane Ian will differ, but the whole basin as a whole, it was a relatively inactive year. But the 2 previous years, very active. I have the statistics for 2021, and then also 2020 was, by all measures, a record season with 30 named storms, 14 hurricanes, 7 major hurricanes. Closer to my neck of the woods, 10 landfalls along the Gulf Coast. So those are the ones that really impact North Florida and inland areas. So what can we say about climate change and tropical cyclones? I'm going to call them tropical cyclones now because they occur in all the ocean basins around the world, not just the Atlantic. The number of tropical cyclones each year has remained relatively unchanged. We have not seen an increase in the frequency of tropical cyclones. And here on the top graph, the top line shows cyclones of tropical storm strength. The bottom graph shows hurricane strength. But again, both are relatively stable with about 90 cyclones per year. But what can we say? Dr. James Elsner at Florida State University published several papers on this, that the strongest storms each year are getting stronger. And that's backed up by work from Kerry Emanuel at MIT, where he's done modeling studies, where he shows the hurricane potential, or the sea surface temperatures and amount of moisture available to fuel hurricanes, is increasing, and thus these strongest storms, the top of the envelope keeps rising. We're also fairly certain that we're seeing increased rainfall from landfalling tropical cyclones. Again, a warmer atmosphere holds more moisture, more water vapor, more available for precipitation processes. Also, there's some other studies out there that show that forward motion might be slowing down and moving a little higher in latitude. So that's kind of changing the storm tracks. A slower forward motion is definitely concerning. That in and of itself would lead to more rainfall and longer lasting storm impacts as it makes landfall. And there's also a climate variability side to that. Without going into a lot of detail, when we're in the El Nino phase or warm water in the Pacific, it tends to lead to unfavorable shear over the Atlantic and a less active tropical season, where La Nina, like we've been in the last 3 years, tends to lead to a more active season. So that's why I say we kind of dodged a bullet in 2022, other than Hurricane Ian. But that's still one of the main factors that goes into the seasonal hurricane forecast from Colorado State University and from NOAA. All right, with that, I think I'm going to go ahead and wrap up and kind of recap what we know about climate change and what we're more uncertain about. And I've listed these, again, weather and climate threats in order of what is more certain, what the science says is more certain. Sea level rise, 100% is going to continue at least the current rate. Studies have shown that rate is accelerating. So we are locked into sea level rise for the next century and beyond. That's almost a given. Temperature, very likely to continue rising as greenhouse gas emissions continue and CO2 concentrations continue to increase. Florida, maybe not as much as other regions, seeing as we're surrounded by water, but this overall trend will continue. Drought. We can't say a lot about seasonal rainfall patterns and if changing rainfall will trigger more or less drought. But even if rainfall doesn't change, rising temperatures increase evapotranspiration and change the whole water balance. So rising temperatures alone can lead to more frequent and longer lasting, more severe droughts. Rainfall, we are fairly certain that we're seeing more rainfall in extreme events. Changing seasonal patterns or regional patterns, a lot more uncertain, as the global climate models really don't handle rainfall processes very well. And again, reviewing with hurricanes, the number of hurricanes may not change much, but there is more potential for stronger storms, surely greater potential for storm surge with the addition of sea level rise, and more rainfall and inland flooding. So I appreciate you listening to me and my spiel on climate and climate change, and I hope you find some applicability to occupational health and safety. Thanks. Okay, I can't run off yet.
Any questions?
Oh, that's the hard part.
So as they warm up, what occurred to me is the warmer nights. I work in heat stress, so we count on that as a recovery time.
Right.
And the other is we tell people just delay the work to cooler times. So the cooler
Yeah, like I pointed out, in the last 8 years, we've had 7 individual months of cooler temperatures. Everything else has been warmer than normal. So I think we can anticipate more of the same with really a high degree of likelihood.
Again, just to build one more time on, I could talk about heat stress for a while. But one thing we also know is that previous days of hot weather increase the risk of heat disorders on a given day. So as that curve shifts, the distribution, we can have more hot serial days.
And again, it's vulnerable populations too. Those that might not have air conditioning. You know, if you have air conditioning, you probably have a good chance of recovering at night. But if you're without air conditioning, that's a whole another threat level.
Any questions? Any other? Yes.
I was just curious if you've had any groups reach out to you. I think of some of our first responder work and the PPE they require to wear regarding policy changes and the impact of how the environment the additional heat stress and things like that.
No, I've not had first responders reach out to me, but I feel certain they are aware of this, and like the graphic I showed was mostly geared to the military, but if you read the fine print in that, they had a lot of allowances for the gear they had to wear and the weight they had to carry and stuff like that. So yeah, it's very much a concern. Question for you. I also read somewhere that especially these overnight temperatures could interfere with pregnancy and could cause more problems with pregnancy. Does anyone know anything about that? Okay.
I can tell you that from an acute point of view, they shouldn't be much of an effect. To have an effect on pregnancy and acute exposures, the mother's body temperature would have to get up to about 104 for a sustained period of time. I know that that's how we talk about that, but for sustained high levels, where the cardiac output might be diverted to the skin,
I remember reading a headline or two, but I didn't dig into it. So
well,
I got a research topic for when I did.
Yeah.
Yes.
Question, as these become unfortunately all too common, and we were talking about the differences between wet bulb temps and all of that, are there any household-based monitoring tools that would equate to like carbon monoxide sensors to potentially alert individuals? Some thermostats in Kentucky only go up to 2 digits on the Fahrenheit scale, and I'd be curious as to like, and then Louisville's done a bunch on urban heat islands and stuff. There's extraordinary inter-city variability on temperature, building structure, age, roof type. I mean, and I'd just be curious if there's any early warning systems that could be, I mean, almost like, I worry about in-home mortality from some of this possibly being greater than what we would see from carbon monoxide poisonings because of the extreme cold we see. So I don't know if that's an innovation that exists yet, or because I could see from emergency responders and for people being able to be prepared to deal with it. I'm just...
I'll try to answer those two questions. One, to really monitor this wet bulb globe temperature, you need weather instruments, the temperature, humidity. They also need to be exposed to sunlight and wind, so you can get those measurements also. So you need an at-home weather station from like Campbell Scientific or something, or Kestrel even makes these handheld units that might be convenient, and that I think a lot of high school sports use to monitor on-field situations. As far as the urban heat island, and I know of one study that's been done in New York City where, along with pollution monitors, they had temperature sensors distributed across the city, And they did some really good work showing where the hot spots were with this network of temperature sensors. But whether that's actually used to do real-time alerts or not, I don't know.
Yeah, there's enough epidemiological data, I think, that we can begin to get a handle on when to warn alert populations that are more at risk than normal with the information we have. Just compare it to the heat index. The heat index works well.
It does work well, yes.
Okay, so we got one master's topic out of this. Some interest. Thank you very much.
Thank you. It was a pleasure being here today.
It says, well, we're 5 minutes early, and then there's a 5-minute break. So I guess we'll go ahead and take that 10-minute break. But please don't wander too far away, and we will reconvene in about 10 minutes.